Hi friends, this is Syed Reshma Sharif. In this video, let us understand the lecture notes of a continuous time signal as well as a discrete time signal. First, let's discuss about a continuous time signal. Continuous time signal continuous time signal. If the signal is defined for all the values of t, such type of signal is called as a continuous time signal. It can be represented as x of t, where x is a dependent variable where t is a independent variable. Okay, here the signal which we have represented as a single variable signal. This is represented as a single variable signal. Okay, let us take an examples of a continuous time signal. So we can draw a continuous time signal on x-axis with respect to its time, y-axis x of t, where this is t, this one is at minus t. The amplitude of a signal is a. This is an example of a continuous time signal. It can be defined for every value of t from minus infinity to infinity for all values of t. Okay, so this is called as a continuous time signal. Whereas discrete time signal, if the signal is defined as only at a discrete intervals of time, listen carefully, if the signal is defined only at a discrete interval of time, we can call this signal as a discrete time signal. It is represented as x of n, where x is a dependent variable, where n is an integer. Let us take a same signal and sample that continuous time signal at discrete interval of time. For this signal, what the value of signal at intervals of t at a right hand side? Let us discuss. Let us represent the signal. This is signal. This is t naught. At time at different intervals of time, t2, t3. Here at the left hand side, same as minus t1, minus t2, minus t3. Okay, in the same way, left hand side, it is represented as minus t1, minus t2 and minus t3. For discrete time intervals of time, we will see for what the values of a signal. Signal is at, what was the signal is at t naught? That is a. At t1, the amplitude of a signal is a. At t2, same, the amplitude of a signal is a. At T3, the amplitude of a signal is 0. Whereas at the left hand side, the amplitude of a signal at T1 minus T1 is A. Minus T2 is A. Minus T3 is 0. This is the discrete time signal. The amplitude of signal is A. At T1, at T2, at T3 it is 0. Similarly, at the left hand side, minus T1 A, minus T2 it's A, and T3 minus T3 it is 0. Similarly, here in between T0 and T1, there is no signal. Similarly, at T1 and T2 also there is no signal. Similar in the same way at T2 and T3 there is no signal. The time signal between here T0, T1, T2, T3, the time intervals of a signal is not defined in the same way at T1 and T2. The spacing between T0 and T1 and T2 as well as T2 and T3 in the same way left side T0 and T1 minus T0 minus T1 to T2 as well as minus T2 to T3 is called that time intervals, or we can call that spacing called as a sampling space. This is what we call in between T0 and T1 as well as T1 and T2 as well as T2 and T3. It is called as a time interval. Or we can call that spacing as sampling space. Time interval or sampling space. Okay. The time interval can be uniformly sampled or non-uniformly sampled. If we can uniformly sample this time interval, the spacing between T0 and T1, T1 and T2, T2 and T3, it will remain same. So we take T0 as 0. We take T0 as 0. The distance between T0 and T1 is as T. Whereas T1 and T2 as 2T. As well as T2 and T3 as T3. From the point, the signal again I am representing like this. T0, T1, T2, T3. Minus T1, minus T2, minus T3. Soften. This is A. This is a here it is 0. Similarly, at left hand side, the amplitude at minus t1 is a, whereas the amplitude at minus t2 is a, as well as t3 is 0. Okay. Here we take a distance between t0 and t1 as t, whereas t1 and t2 is 2t, whereas t2 and t3 is t3. Similarly, at the left hand side, it is minus t, minus 2t, minus t3. Likewise, last term is up to nt. Here also up to minus nt. Okay, likewise, the last term nt, if we remove t from this term, we will left out only with 0, 1, 2, 3 up to n. This signal is represented as zero, 1, 2, 3 up to n. Minus 1, minus 2, minus 3 up to minus n. Where we already take the signal with an amplitude of a. This is also a, this is also a, it's 0. This is a, this one also a, so this is 0. At minus 3 it is 0. Okay, so at 0, 1, 2, 3 up to n, in the same way at left hand side at 0, minus 1, minus 2, minus 3 up to minus n. We got an amplitude as a. Instead of these, we represent it as n. Instead of t, here instead of t we are taking as n. Okay. Sorry. So we can observe in a discrete time signal, in this discrete time signal, 0, 1, 2, 3 up to n. But there is no signal between 0 0.5, 1.5, 2.5 likewise. Sorry. Always we have to remember it will be represented with a whole numbers. Mathematically, we will write this signal as x of n is equal to 0, a, 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 a. We start from this, we started the signal from this side. At minus 3 it is 0, at minus 2 it's a, at minus 1 the amplitude is a, at 0 again amplitude is a, at 1 the amplitude is a, at 2 the amplitude is a, at 3 the amplitude is 0. Okay. So we'll write this signal as x of n is equal to 0, a, 0. But with this, we do not find where is the origin. So origin we have to take in between which we need to identify origin. We need to write at the origin. This is origin. Where at negative side, this is at -1, this amplitude is A. At -2, the amplitude is A. At -3, the amplitude is 0. Okay. Whereas at right hand side, the amplitude is A. Whereas at 2, the amplitude is A. At 3, the amplitude is 0. Okay, in this video, we understood how the sampling a continuous time signal at a discrete interval of time, and we have written a discrete time signal from a continuous time signal. Thank you for your watching. If you have any doubts regarding this, please do comment